Hi, this is Urs Shapiro of the Dr. Vax channel. As we struggle through the second wave of COVID worldwide, and it does seem when we get together in a video conference, we end up debating and arguing about politics, I have found a wonderful way to bring joy, satisfaction back into our lives. Make something. When you print a 3D printed vase, this is from the Prusa repository, printed in a wonderful silk style filament. When you turn items on a lathe, these are turned in various woods on a lathe. When you design and print a custom bread knife as a gift, when you make things, you create things, it generates joy. It's a wonderful sense of satisfaction creating something or reproducing something, and it's even more satisfying giving it as a gift. So while the world around us seems to be blowing up, we're going to spend some time learning about 3D printing. Now, I've produced about 150 videos, maybe 110, 115 of those about 3D printing over the last 2 years. And I get the same questions over and over again. People new to 3D printing seem to have a common set of problems. I'm going to address those problems today. But even if you're a 3D printing expert, you should watch every minute of this video. You should subscribe to the channel. You should give it a thumbs up. You should click on the bell so you'll hear about new videos, because I'm going to cover a lot of material. You might find one thing at 1 minute in the video that helps make it easier for you to successfully complete 3D prints. So stay tuned and let's learn something together. Now I'm going to get started with a real basic. There are many different types of build plates. This happens to be a build plate that fits on my Ender 5 and my Prusa i3 MK3. It's a spring steel style of build plate. That means that to get the build off, you flex the plate and the build comes off. Here's a build plate from a Ender printer that has the magnetic style of build plate. They're not using these anymore in the new Ender 2 V2. The build plate on this little printer here, which is a Monoprice Select Mini, is a fixed build plate. There are many types of build plates. But universally, your goal is to have the print stick to the plate when you're printing and release when you're done. Now, there are a lot of techniques for doing that. They all start with one thing: level your build plate. Yes, I know, a lot of the new printers have auto bed leveling systems. Still, when you first take your printer out of the box, if you assemble it or if it comes pre-assembled, level the build plate. Now, here's a picture of the knobs you would use to adjust the corners on an Ender style 3D printer. Basically, the procedure is the same. There are a bunch of videos. I will link some above on the Dr. Vax channel about leveling the print bed. But the message I want to leave you with is, even if you're using auto bed leveling, first level your print bed. Now, there's a limited number of 3D printers where you can't manually adjust the print bed. The Prusa i3 MK3 is an example. In that case, and this universally also applies, make sure everything is tight. That when you assembled it together, you tightened everything really finger tight. You don't want to over tighten components, but you don't want them to be loose. You want everything tight and rigid and square. Then in the case of the Prusa printers, there's a procedure built into the firmware that will check to see if the print bed is level. And there's a new procedure in the newer firmware where you can manually adjust each corner, which is the equivalent of leveling your print bed. Now, if you don't have software built into your printer to level your print bed, you still can use software to automatically move the print head to each corner. And I'll link a version of that software. It's a G-code file, and links to a video down below. So, number one problem that you see is things don't stick to the print bed. Number one solution is, even if you're using ABL, auto bed leveling, level your print bed. The second solution is using a print bed adhesive is not cheating. Some people like to use regular glue sticks. Some people like to put blue masking tape on top of their print bed. Some people like to use Windex. I'm a big fan of a product called Magigoo. Magigoo works for me consistently. This is not inexpensive. This little tube is about 19 bucks. A tube like this will last me, and I do a fair amount of printing, about 6 months, maybe a little bit longer. But I'll tell you, you're printing something big and you get to here and it comes loose on your print bed, that's a bad day where you've wasted hours and hours of time. So invest in a print adhesive. I've tried a bunch of them. This one works best for me. Now, the next problem that I see people having most often. First, if you're new to 3D printing, you have to grasp the idea that you take a model that is a three-dimensional model that's saved in a format often called STL, which is where the model is made up of individual triangles. I'll show you a picture here on the screen. But your 3D printer prints a layer at a time, moves up, prints another layer. So you have to divide it into instructions about how to print a layer at a time. So you're converting your STL file often to a file in G-code format. Not always, there are other formats, but G-code is the most commonly used. The program, as many of you know, that you use to convert from a three-dimensional model to G-code is called a slicer. Most slicers, though, come with a built-in capability designed to make them easier to use. And that is, they have beginner or basic and intermediate and advanced modes. The most common problem I hear about with slicers is that, and you can see it in the picture here, is someone's in the slicer, it's set to basic mode, they watch a video talking about a parameter, they go to the Dr. Vax forum, the discussion group, forum.drvax.com, they go into Facebook, and they hear somebody talking about something, and they can't find it in their version of the slicer. Do they have the wrong version of the slicer? Is their slicer broken? No, most of the time, it's just that they didn't turn on the advanced mode that makes all of the features visible. Problem number 3. People find 3D printers too slow. A vase like this, printed with a 4.4 millimeter nozzle, in vase mode, will still take 3 or 4 hours to print because it's large. So the first thing people do is they find the speed setting on their slicer and they set the speed up. Or they go to the front panel of their printer and they crank the speed up. And then their prints fail. So in general, high speed is bad for quality in 3D printing. Now, depending on the quality you're looking for, you might not care. Because what happens when you go faster? Well, your printer takes less time on each layer. Maybe that layer doesn't cool completely. Your printer is vibrating more, depending on the style of printer. So you get layer shifts. That's where the layers don't line up perfectly. Or you get a phenomenon called ghosting. We'll look at that in a moment. So if you're having trouble, the first thing you should try is slowing down your prints. I'd recommend slowing them down to 30 or 40 millimeters per second, depending on your slicer. And then once you get things tuned in, you can speed them up again. Now, it's not just speed, overall speed, that impacts how long your print takes to print. Because a Prusa direct extruder printer, which is about the same size as an Ender 3 printer in terms of print volume, is significantly faster. 30, 40, 50% faster depending on the print. So what impacts that print speed? Let's look at this slide together. The first thing is retraction. To review for everyone, when you're going along in printing and then you want to move the nozzle to another area, and you're not extruding, you're not pushing out filament during that move, you don't want filament dropping from the nozzle. So you retract the filament. That reduces the pressure on the nozzle in order so it won't cause stringing across the layers. Now, on a Bowden style printer, this is a Bowden style printer because there is a tube between the extruder and the hot end. On a Bowden style printer, there's a lot of play in the system. This tube is flexible, the filament's going over a long distance, so typical retraction might be 4 to 6 millimeters, pulling back a fair amount of filament. That takes time. Every time you retract, slows down your printer. On a direct drive printer, I have a Monoprice Ultimate 2, I have a Quiddy X-Smart printer, I have a Prusa i3 MK3 on a direct drive printer where the filament goes right into the hot end and the extruder, the mechanism that pushes the filament, is right on top of the hot end. There's less play. So typical retraction might be a fraction of a millimeter to maybe 1.2, 1.5 millimeters. That takes less time. So the more retractions in your print, the slower it will print. You could turn retraction off completely, you'd get a lot of stringing, but your prints will print faster. So fine-tune retraction. Let's look back at the slide. When you're producing a print and you have perhaps, let's say, multiple towers at various points on the print, at times the nozzle sometimes will seem to clip an item. Well, you can avoid that by turning on Z-hop in your slicer. That means before you move the nozzle up, move, put it back down. Takes a lot of time. You want to print faster? Print at slower speeds, but with Z-hop off. Let's look at the next item. There are two parameters that are often hidden deep in the bowels of your slicer. The first is minimum layer time. So find out where minimum layer time is in your slicer. Now, how do you find that? Well, Google's your friend on all this. You can type into Google Cura minimum layer time, Prusa slicer minimum layer time, Simplify 3D minimum layer time, and very often you're going to get the answer. It's really easy. If you have the minimum layer time too small, you're on a layer that has very little printing, you're going to move to the next layer very quickly. That layer is not going to harden, not going to cool before another layer is put on top. And that will cause additional stringing. It will also cause your layers to sometimes shift, and you'll get failures. So let's look at a video here, and you'll see what happens when you're printing too fast, where you have little points in the corner, and you don't leave enough cooling time. Sometimes your print will actually warp up, and the print head will hit it. You'll see that in this video. Next, there's another sort of hidden feature in slicers called maximum segment size. So you're dividing up this print into moves on a layer. You're not actually printing dots like an inkjet printer. You're printing segments. There's a parameter in Cura called maximum segment size that says how large those segments can be. If you make it very small, your print head has to adjust more often. That's going to slow down your printer. It's also likely to cause bumps or sort of defects in your print. So you can increase that. It'll speed up your prints a little bit. Your prints will be less precise, but they'll be smoother. And finally, let's look at two advanced parameters in 3D printers and in 3D printer firmware called acceleration and jerk. The green line across the top is the speed we want to get to. Now, we can't get to that speed instantaneously. The speed of light isn't even instantaneous. We have to sort of move up to that speed. It's like you're stopped at a stoplight in your car and you want to accelerate to 40 miles an hour. It doesn't happen instantaneously. You can accelerate slowly or you can accelerate quickly. The more quickly you accelerate, the more you jerk around the passengers in your car. The more quickly you accelerate on a 3D printer, the more you jerk around your print, causing defects or artifacts in your print. So if you reduce the maximum acceleration, you'll accelerate more slowly. Your prints might be more beautiful. They'll take longer. When you're going to come to a stop, same thing in a car. You hit the brake pedal gradually and you ease to a stop. You don't slam on the brake pedal. That's called jerk control. Now, you'll see on this slide, on this picture, what happens if you have these set too high. You'll end up with ghosting in your print. So if you turn off jerk control, acceleration control, or you set them way too high, you'll get this shadowy effect. If you look at the Y, you'll see it looks like there's multiple Y letters on this print. Those are called ghosts. So if you see that in your print, you want to lower acceleration, lower jerk, potentially just lower speed. Next, what temperature should you print at? You should print at the lowest temperature that will give you good layer adhesion. What does that mean? Well, once again, 3D prints are actually printed in layers. It doesn't matter what you're printing, they're printed in layers. You want the layers to stick together. 3D prints are very strong in this horizontal direction because it's the strength of the filament. But in the vertical direction, where you have one layer on top of another, they need to stick together. If you print at too low of a temperature, the layers won't stick together. If you print at too low of a temperature, you'll cause a second problem. Your extruder, which is responsible for pushing the filament to the hot end, won't be able to push it out the nozzle. It won't be soft enough, liquid enough. If you hear clicking from your extruder, it is likely that you're printing at too low of a temperature. So you say, why not print at a really high temperature? Well, if you print at a really high temperature, when you go to move your print head on a travel mode where you're not extruding, more filament's going to drip out of that nozzle. That's going to cause stringing. So if you have too much stringing, you're probably printing at too high of a temperature. What are other things that happen if you print at too high of a temperature? Well, where your print sits on the print bed, it might actually spread a little bit. That's called an elephant foot. That also can be caused by having your print bed temperature set too high. How high should your print bed temperature be set? Just high enough so your print sticks, it doesn't move around, but no higher than that so it won't spread and create elephant feet. So you need to fine tune your print temperature. Here's the gotcha. It's probably a little different if you want to be perfect for every filament brand and sometimes even for colors within the same filament brand. It is definitely different for different styles or chemical makeups of filament. PLA, PETG, ABS, all print at different temperatures. Now, the next problem is primarily a problem with Creality style printers. They have an anomaly that many people have copied, or a design decision that many people have copied. Let's look at this picture together. In an all metal hot end, the Bowden tube comes to the top of a metal tube that then goes the rest of the distance to the nozzle. In a Creality style printer, the Bowden tube has to go all the way down to the nozzle. It has to be pushed all the way down to the nozzle. On the ANET ET4 series, same way. On many Creality lookalikes, same way. So on that style of printer, very often, if you're changing your Bowden tube or you're adjusting it, you're pulling it out to unjam a printer, we'll talk about that in a minute. If you don't push it all the way down, you'll end up with a gap between the bottom of the Bowden tube and the top of the nozzle. That gap will fill with filament and cause jams. So the most common problem I see people having with this style of Creality, I'll call it a Creality style hot end, is that the Bowden tube isn't pushed all the way down. Now, to be proficient at tuning and maintaining and supporting your 3D printer, you need to understand how the various components work that connect together the extruder to the hot end. Now, I took this printer here as an example because it's just very easy to show everyone all of the parts. This is a Monoprice Mini Select printer. It's very small, fits on my desk. This component, once again, is the extruder. This component is the Bowden tube. This component is the hot end. On each end of this tube, you will see that there's a coupler. When you press down on the top of the coupler, it releases the lock. So if I have this coupler on a Bowden tube, if I try to pull it off, it won't come off unless I press down on that black ring when I go to pull it off. So you have to understand how these components work together, which will take us to the next section of this video, where we'll talk about unjamming a jammed printer. I've repositioned the printer with a camera on it so that I can show you close-ups of what I'm doing. So the first thing we need to know is that sometimes a jam can be unclogged in a really simple way, and it's really just caused by the fact that your extruder can't really put quite enough pressure on the nozzle. So what I'm going to recommend you start with is turn on your printer, and using the front panel of your printer, set the temperature to about 10 degrees, at most about 15 degrees higher than you would normally print your filament at. You don't want to go 30 or 40 degrees higher because filaments can burn and that causes other issues. So about 10 or 15 degrees. Generally, this should be in the range on the label on your filament reel at the top end of that range. So we're going to go here on this printer, you go to something called preheat. I'm going to set this to about 215 degrees. And now we're going to let this heat up. The idea is that making it a little hotter will make the filament a bit softer. And then I'm going to manually, by releasing the spring on the extruder, manually push the filament through. Now, some styles of extruders don't have the spring mechanism, some of the higher end direct extruder printers, so you may have to use the front panel to tell it to extrude filament. This will work for a large range of desktop 3D printers. Okay, we're up to temperature now. So now I can push on this spring here and then push the filament in manually. And if I want to push on the spring enough so the filament is free in there, and I should be able to see some filament coming out of my nozzle. Now, if I'm able to do that, one trick to avoiding clogs in the future is before you're going to pull your filament out, always push it in a little bit. So push your filament in, and if it's coming out, then pull it right back. So often you can unjam a nozzle just by heating it a little hotter, pushing it manually through. What if that doesn't work? Well, then let me show you a couple other techniques. Now, the next thing you might want to do is try to pull off the Bowden tube on the hot end side. So press down on the nozzle and see if you can pull out the Bowden tube. Now, if there was still filament in there, you'd see the filament from here to here, and then you can heat up the filament, push it in a little, and pull it out. But if after you pull your filament out, your nozzle still seems to be clogged because you're not getting good prints, take a piece of filament, cut it off straight on the end, and then straighten it out. Now, your Bowden tube is out here, so you have access directly to the coupler. Now take with your printer at temperature and manually push the filament through. Now you can put a lot of pressure here, a lot more than an extruder could, and so you should be able to see a nice thick bead, the full width of your filament, a little more than you would typically get with an extruder. Then pull it back out. That is another technique that will often unclog a filament. So you release the coupler from the Bowden tube, you take a piece of filament and you manually push it through. Now, if that doesn't seem to clear it, you can buy a cleaning tool. I bought this on Amazon. This is from Reptor. And these come with different size needles for different size nozzles. This is for a 0.4 millimeter nozzle. So you can put this in the top and actually push it through until you see it come out the bottom and go back and forth. Now you do need to do this with the nozzle at temperature. Now finally, there will be times where you can't get the Bowden tube out of the coupler. In that case, you'll actually have to take a spanner, a wrench. These come with most of the printers. All the Creality printers, as an example, have one. And you'll have to manually unscrew that coupler. Now, I've never had to do that on this printer. I do it on my Ender printers all the time. And the reason is that with the Bowden tube going all the way down, sometimes the coupler grips it a little too tight and you can't get the Bowden tube out. And then if you unscrew the coupler, you can pull it all out together. So you would take this wrench, unscrew the coupler. When you go to pull it out, the nozzle will have to be hot, so be very, very careful. Well, folks, I hope this video has been helpful. Those are some of the most common problems I see in 3D printing. If this was helpful to you, subscribe to the channel, click on the bell, recommend this video to everyone you know, and most importantly, go to forum.drvax.com and discuss your 3D printing problems and solutions with hundreds of other viewers. Thanks again for watching. Let's continue to learn things together.